Lesson 2 for forces in motion, significant figures when we're multiplying and dividing. Before we look at significant figures when multiplying and dividing, we will look at the units. When numbers are multiplied, the units merge after factoring out what is present in both the numerator and the denominator. In our first example, we don't have anything that can factor out in the numerator and denominator. So we'll simply merge the tops. So this will equal meters on top divided by, well, we have two s's on the bottom, so that would be seconds squared. Now let's say we have a question where it says we have meters per second squared multiplied by seconds. I would want you to write meters per second squared, and then we're going to multiply by, we're going to change seconds into a fraction. So that would be s over 1. Now we factor out what we have in common on the top and the bottom. So I can take an s off the top and an s off the bottom. And then I merge what I have on the top, which is meters, and I merge what I have on the bottom, which is just seconds. Now if I had meters per second squared multiplied by seconds squared per meter in the question, meters and meters would factor out, seconds squared and seconds squared would factor out, and that would leave me with no unit. Rule number 2, when you have two numbers that are dividing, the units in the second number are inverted. They are then merged using the same rules as when we were multiplying. So meters per second divided by 1 over seconds, we're going to write meters per second. We're going to change division to multiplication, and then we flip the second fraction. So 1 over seconds becomes seconds over 1. We then factor out anything that's the same in our numerator and our denominator, and since we have a seconds on the top and a seconds on the bottom, they can factor out. That will leave me with an m on the top and a 1 on the bottom, which m divided by 1, we wind up with just m as an answer for our units. All right, if we've got a unit of meters per second, and that's being divided by a number that has units of seconds, and I want you to write those as two fractions. So we'll write meters over seconds divided by seconds over 1. Now, when we have division, again, we switch it to multiplication, and then we take the reciprocal of the second fraction. So that will then become meters per second multiplied by, we flip the second fraction, 1 over seconds. We factor out anything that's the same in the numerator and the denominator, and there's nothing here to factor out. So that means I wind up with an m on the top divided by, and I have two s's on the bottom, so I write seconds squared. Now if I had meters per second squared divided by meters per second squared, again, I would write the reciprocal of the second fraction, so I change it to multiplied by seconds squared over meters. Seconds squared and seconds squared will factor out, meters and meters will factor out, and in this situation, I would wind up with a number being calculated that has no unit. Well, what about the numbers when we're multiplying and dividing? What happens to them? Well, when we multiply or divide, the answer has the same amount of significant figures as the number with the least significant figures being multiplied or divided. That may not make a lot of sense right now, but when we get into the examples, that's going to become clear quite quickly. I also want to point out the rules for adding and subtracting are different than the rules for multiplication and division, and they will be studied in future courses. Example 7, 23.0 meters multiplied by 0.032 meters per second. I'll punch that into my calculator, and that gives me 0.736. Now I'll look at the two numbers being multiplied. 23.0 has 3 significant figures. 0.032 has 2 significant figures. Now, as stated in the rule, my answer is only allowed to have the same number of significant figures as the least number being multiplied or divided. 2 is smaller than 3, so my answer is only allowed to have 2 significant figures. And since zeros in the front cannot be significant, That means the 7 and 3 are significant and the 6 will not be, which means I will have to round it off. So my answer only has 2 significant figures. So that's going to give me 0.74. Now to work out my unit, again, I like to write them as fractions. So meters would be written as meters over 1, and I'm multiplying that by meters over seconds. Nothing factors out, so that is equal to m times m on the top, m squared, divided by just a single s on the bottom. So my answer is 0.74 meters per second squared. Example 8. 5.20 meters divided by 0.1032 meters per second. I'll punch that into my calculator and I get 50.3875969. The first number, 5.20, has 3 significant figures. The second number, 0.1032, has 4 significant figures. 3 is smaller than 4, so my answer is allowed to have 3 significant figures. So the 50.3 will be significant, but the rest will have to be rounded off. When I drop the 8, it will bump the 3 up to a 4. So 50.3 becomes 50.4. Now for our units, we have meters divided by meters per second. And again, I always want you to write them as fractions. So I won't write just meters. I'll write meters over 1 divided by meters per second. So meters over seconds. When we have division, we want to change it to multiplication, and to do that we have to take the reciprocal of the second fraction. So meters over 1 multiplied by meters over second becomes seconds over meters. And now I have a meters on the top and bottom that can factor out, and that will leave me with an s on the top and a 1 on the bottom, which is written as just s. So my answer is 50.4 seconds. Example 9, 2.5 meters multiplied by 1,570 meters. I punch that into my calculator and I get 3,925. 2.5 is 2 significant figures. 1,570 has 3. So that means my answer has 2 significant figures. So I will keep the 3,9. I will have to round off the 2,5. When I do that, it does not give me 39. I point this out because it is a common mistake that grade 10s make. 3,925 cannot become 39. 3,925 becomes 3,900. Now looking at our units, we have meters multiplied by meters. So I'll write meters divided by 1 multiplied by meters divided by 1. Nothing can factor out. I have 2 m's on the top, so that gives me m squared on the top, and on the bottom I have 1. And I write that as meters squared. So my answer is 3,900 meters squared. And that's the end of our lesson.